Hello.
Hello.
How are you?
Good, good, good. Doing okay. Bring in Steve in.
All
Hello.
right. Yeah, hello. How's it going?
Really long
How are you
day.
both? Yeah, no kidding. You and I started early today, huh?
Yeah,
You,
yeah,
Samson and I have been
yeah,
like straight up co-working today.
yeah.
Stev, are you excited about the Buenos Aires hackathon this weekend?
Oh yeah, I'm pretty excited, and I'm more excited because I think there's a new midnight prop there. So
Oh, I saw that on Twitter just now.
oh, they posted already. Okay,
Mhm.
so the beans are out. There's a midnight chainsaw.
Yeah.
So I'm excited to bring the shield there, but I think the shield it's protected by ZKP, so I don't know if the chainsaw will penetrate unless they share the same proving system. Then I don't know. That's a terrible joke, but
That was
yeah,
that was
I'm excited.
excellent, excellent, excellent. Sweet. Okay, cool. Well, hello everyone. Thanks for saying hi. Hi, Eric. Hi, Jay, John. So excited that you're all here today. We have a bunch of stuff that we want to talk about. Um, no, Samson, that's an old message. No worries, you're good. Um, does it work for real? I actually have been curious about that too. Does the chainsaw work? Do you know?
I have no idea. I saw the picture. It looks
I
like
kind of hope it
the teeth are
doesn't.
still on it.
Uh, um, okay, so I sorry, I'm messaging Samson really fast a bit. Hi, all. I want to kick things off today with talking about the new challenge that we are launching because today kicked off a new hackathon, and we let's see, are still within the mini DApp hack. Like that is still right now happening because we have our final showcase on Friday. So please, please, please hit a reminder for yourself to join and watch that on Friday. It's a couple hours earlier in the day, but it'll be awesome to see the demos of the projects. We have some really cool projects that were submitted for that one. But just because one hack ended doesn't mean that more aren't happening. So we recently launched with in partner and collaboration with Dev, a midnight privacy challenge or privacy first challenge. And so if any of you are new to us and come from they're hosting a stream right now, or they're hosting this as well. So if you're joining us and finding us via that, quickly give you an overview. Midnight is a blockchain that's focused on privacy, data protection, and honestly, our mission, our team, Stev and I, Samson, all of us, we really are passionate about giving developers tools to build apps that, respect individual privacy, make it scalable, make it secure, make it compliant. And so that's what this challenge is all about. And it's going to be running through September 7th. And we want you to build privacy enhancing applications, as well as developer tools using zero knowledge proofs on Midnight. So there are two main prompts that we're doing within the hack, and I will try and make sure that I get you the link to the hack or itself. I'm going to share it with you, Samson, if you could pop it in into the chat. The first prompt is protect that data, and that one is just about building on Midnight and using Midnight's compact language and Midnight JS. And we want you to think of projects like confidential job boards, private voting apps, CK powered games, anything that would benefit from that disclosure, obfuscation, deciding what you do with that data. Anything where privacy is a core feature is welcome and fair play. And the top project for that, or top prize for that, will be $3,500, as well as a Dev plus membership and a winner's badge. And those badges within the Dev platform are very cool and very fun to have and collect. And then the second one is enhance the ecosystem. And so this is around tooling. So it's about improving the developer experience, about building on Midnight. So improve the life or the experience of a builder in our world. So it could be a CLI tool, a ZK playground, a dashboard. We've seen integrations when we've run this challenge in the past. But yeah, think what would make your life as a dev more, easier, nicer, more positive. We actually recently have a blog post on our dev blog, our technical blog, about a hacker who was participating in a different hackathon and ended up participating in our tooling challenge as well, because he was frustrated with an experience and was like, I'm just going to build this for everyone. And oh my gosh, how perfect that there was a hackathon happening at the same time. So that might be a good inspiration to go give that a read. And the winner for the Enhance the Ecosystem track is the prize is $1,000 plus the Dev Plus Plus membership and a winner badge as well. And then lastly, we're doing a bonus, if you will, for the best tutorial. Because it's dev and it's ultimately a blogging platform first and foremost, we're rewarding the best educational content. So the most clear, engaging tutorial, regardless of either of the prompts that you've chosen, it's $500 plus, in addition to potentially the other prize that you could win. But we really care about bringing devs along for the journey, giving educational content, and helping them understand how to build what you have built also, and making that accessible. So that's why we have that prize in addition. You will definitely, I think, with speaking back to the badges piece, any participant with a valid submission will get a completion badge. Hi, Sergey. And so even if you don't win, you're walking away with something that shows that you've built on Midnight, which is awesome. But more importantly, it's your chance, honestly, to get started, get your hands on with ZK Tech and add to your portfolio, right? It's a way to share your work with one of the largest developer communities in the world. And so, yeah, that's ultimately why I'm so stoked about this partnership. I think it's an opportunity to find a whole lot more devs and expose them to Midnight. We have everything listed out in the Dev Challenge page. And there are links also within that to our docs, our tutorials, our quick start guide, and all of that. And just a reminder for anyone curious about this, we are on testnet. There's not a cost to try things right now. Grab test tokens from our faucet and just start building, and you can kind of be off to the races. So we start today. Submissions are due on the 7th, and we will be announcing the winners on September 18th. And yeah, we're stoked to see what you're going to build. I think it's a call to action for even if you were deep in ZK Tech, or just a newbie and you're curious about privacy. This could be an awesome way to kind of get started and jump in. We have a Discord, we have a forum. We'll spin up a particular channel within our Discord for the dev participants to talk and kind of get attention in there. And yeah, our Midnight community is robust and very powerful. It's a really active group of awesome humans. A good place to ask questions and share your progress in there. But yeah, thank you to Dev for partnering with us. We are, so stoked that this is happening, and I'm grateful that you all are here. And we're excited for you to go build something awesome. I think was there a question? Oh, I think that wasn't about. Ooh, maybe a good idea. I agree for the Catalyst Fund project. Interesting. Yes. On our DevRel team, Claude is one of our DevRel engineers is building out a Dex right now, but we also have partners that are working on this too. And I believe he's open sourcing his first he's open sourced the repo, and I think he's putting the contract in this week. So yeah, definitely stuff that's happening, and could be a good use case, honestly, for this hackathon too. That's a TBD. Good question about whether or not we will have a catalyst or a Cardano, if you should apply within the Cardano project catalyst. We are working to have grant programs within Midnight. And so we haven't launched anything yet, but yeah, we will look to have our own and make sure that we can reward people and incentivize, pay people for building great things. So that's important, right? We're also looking to launch an ambassador program really soon too. So taking things from other ecosystems, Cardano, of course, but others as well, and just kind of trying to make the best or take the best practices and build the most robust community we can. Okay. If I'm doing a where do I learn more? Except docs. Already checked. Yeah. Docs are like the first place, of course, right? Actually, kind of right now is the perfect place to start, wouldn't you say? Because Stev is here and he's going to walk us through getting started. So here, right now, it's almost as though we paid you to ask that question, which we didn't. So much good stuff, John, right? Like totally. Yeah, it's a bit overwhelming when we start talking about all the things that we're launching and doing and excited about because there's so I mean the amount of hackathons that are happening just right now is wild. So like Stev is going to be in Buenos Aires for a hackathon in a couple days also. So if you're there, participate in that too. I mean, that's like a double hack, but yeah. Anyway, Steph, I'll let you take over and drive today. But thank you for letting me kind of kick off the dev challenge.
Oh, thank you, Lauren. Yeah, so as Lauren hinted, I'm going to be doing I'm actually going to write a Hello World application for a lot of people who might be new or maybe you're familiar or you might want to, you can follow along if you want to as well. But before that, I wanted to give you all a little taste of some of the presentations at Rare Evo. It's really good for, it was really good for a lot of newcomers because when we're at Rare Evo, sometimes, you know, a lot of people know about Midnight, but it's also sometimes people, it was their first time learning about Midnight. So Joe and Ben from Shielded did an amazing presentation on Midnight's architecture. They also about Compact's architecture. I think there's a video coming out for that, but I literally took some of that presentation and I wanted to share some of that with you all as well because I thought it'd be valuable. But yeah, let me try to share my screen. So we're going to talk a little bit about Midnight and Midnight smart contracts, and then we'll go on to just writing a simple Hello World application and talk about why where this Hello World application is. And I don't think we have much of a Hello World application within our docs, and I'll go into some of the stuff that we'll be working on. I usually talk about SPO stuff. I don't really do a lot of Compact stuff. At least a lot of people don't see me talking about Compact. So this is a fun opportunity. So I'm going to share my window here and hit share. And I think it has to be added into, is my screen, does everyone see that window? I guess so. All right, so that, yeah, there it is. Cool. All right, let's see if it's working here. It is. All right. So yeah, I'm excited to dive into the topic of private smart contracts on Midnight. And as some of you know, Midnight is a partner chain to Cardano. So in this little presentation here, which is kind of a light version of what Joe and Ben presented, I'm going to talk a little bit about how Midnight brings privacy to the forefront. Oop, gotta click in here. So, so why Midnight? So utility and blockchain shouldn't compromise privacy or ownership. I think many of us, at least a lot of us, believe here in the Midnight communities, you know, privacy is fundamentally a human right, especially in our digital age where it's really hard to obtain that right to privacy because all your data is just everywhere. It's replicated everywhere. That's just the reality we live in, and that's what we're trying to solve. And we're trying to make that better with Midnight. And you know, if Midnight we can reclaim like essential freedoms like association, commerce, and expression. And I think this is where we define what a fourth generation blockchain should be designed to solve. So that's why we have Midnight. Some of you have seen this before, but if you haven't, let's start by, you know, contrasting traditional web applications. So these systems often send sensitive and private data across the internet, and it's exposing it to all kinds of intermediaries. So you're sending all these data packets to a traditional company server. This can be misused. It can be hacked. And even the company becomes liable for that data. And this is even more so in a very highly regulated industries like healthcare, education, military, and in many cases in AI, because people have to deal with GDPR compliance. And in AI, you can argue is it's arguably out of everyone's public data. So now AI models are really hungry for your private data. So, and many of us can think of all kinds of situations where there's been data breaches, etc. Now, in contrast, or not in contrast, but let's look at public chains. So in public chains, it's kind of pseudo-anonymous, but it's still open for correlation attacks. So you have all these data packets going to the public blockchain, and if any of you know, of like, I was going to name a specific company, but a lot of companies and that specialize in cryptocurrency analysis and stuff. And and public blockchain is actually extremely trackable. So all they have to do is, blockchain is just at the end of the day, it's a service on the internet with an API. So if you have a pseudo anonymous public blockchain, the company just needs to, connect to the API, and then they capture all the data and correlate it. And, blockchain's been around for 20 years, and this stuff has been around for 20 years. And this really leaves room for a lot of correlation attacks. So one good example is, like there's DAOs, treasuries, and all these other things. Someone dislikes how you voted on something, they could just take that hash of your vote and try to terrorize you in some way, which is very unfair and malicious. And, in ways Midnight can solve those things where people can, exercise their voice on chain and, respect their privacy, autonomy, and minimize those correlation attack risks. Let's go to the next slide here. So on Midnight's dApps, we have, this is where things change a lot, where you can have that private data off-chain, and you're only submitting proofs of that data. And that could be in the unshielded ledger or shielded ledger. And you can still have your metadata protected on the unshielded ledger. And this changes the game, because now companies and services and outsiders, they're not getting all that metadata. There's only proofs, and maybe only someone who's qualified can verify that private data. But the cool thing about private data is when you're sharing proofs, a proof is really just to, a zero knowledge proof is really just to prove that a statement is true without revealing the data. So when you have private data off chain and you're able to submit a proof and update the contract state, which doesn't have the personal data itself, that's extremely powerful as far as changing how we think about applications. All right. Oh, sorry, I was just checking the chat for questions. All right, so let's continue on. So here's like private data and how private data works in transaction. So you can see here in the graph where we start with the Midnight blockchain, which basically is on the right side here, and you have these I guess you say Merkle trees with all these different Merkle roots or nodes. And when you want to, I guess, change a transaction or contract, or you can even call it a contract, kind of like a transcript, for example, you still have your private data on chain, but you would submit a proof to that contract, and that proof goes on chain and simply updates the contract or transcript with a new node. So you're never updating the contract with like personal data and things like that. So it's a much, I would say, Midnight's method of doing transactions and smart contracts is just far more superior as far as data protection. Now, as far as Midnight's architecture, this would be the architecture of a dApp. And but some of you have seen this before. It's probably still in our documentation somewhere. And so, but if you're new to this, people write smart contracts, which we could go from the left-hand side here. People write a contract specification, which is compact. They might have their typical TypeScript dApp code. It doesn't always have to be TypeScript. We've seen people like compile directly to compact with Rust. They just targeted the VM. That's a little bit more hardcore usage. But as far as most of the tools for compact, it's designed mostly for that TypeScript, JavaScript developer in mind. So when you see TypeScript dApp code, you could consider this more as like a typical Node.js application that uses like the Midnight.js libraries and stuff. So the compile, but anyways, the dApp developer system here, which you see on the going to the right now, we have the compact compiler. So that's where you would have your compact syntax, and then you would compile that into into the artifacts and the proofs that would get deployed on chain, and that would get deployed to the blockchain, and people interact with that using let's say, for example, their web browser and the Midnight Least Chrome extension. And something else here is we have the proof server, we can see on the bottom. So in order to submit proofs, you have to, when it comes to zero knowledge proof applications, there's a shared proving system. So which is basically, you could kind of consider that's the mathematical algorithm that compiles the transaction or the smart contract into that proof that gets submitted on chain. All right. Now, kind of getting into more the partner chain side of things. I like this, and that was shared in Rare Evo, but Midnight is kind of buying Cardano as a service. It's a very mutually beneficial relationship. So, and there's kind of like three things, maybe more, depending on how you want to see it. But, and there's a lot of small to mid-sized SPOs that I was meeting in Rare Evo, and I really want to stress to SPOs that might be on this call as well. It's good to be involved into Midnight because, as you can see here, Midnight's probably going to change the SPO game. So like you have a lot of people competing for delegation. It's decentralized. People are marketing like, hey, this is my SPO. This is how I'm unique. This is why you should delegate it to me, etc. Now, what if you have all these delegators that can earn Night and SPOs that can earn a Night? So that's something to consider. I think it's really, I want to encourage as many small and mid-sized SPOs to get involved in Midnight as early as possible because a lot of larger pools and institutions might be a lot slower to move on to Midnight validation. And it's not every time that SPOs get something that's novel and new and they could potentially have a first mover advantage on. That's just something I would encourage people to consider. All right, now let's talk about Compact. So as far as Compact, Compact's design goals focus on basically three pillars. First, we have public and private interoperability, and this allows seamless expression of computations and data across boundaries, and that's to maintain integrity to ensure which is ensured by ZK circuits. Now, second, there's safety, and with tooling to help developers reason about privacy. So in Compact, we have the Compact stack's getting better, but we have things where you can describe what's in the ledger, the witness, what's a witness, and also when you're developing an application, you generally have that private data off chain, so that also contributes to safety. Now, the third thing is familiarity. So so the compact development environment kind of draws on the ergonomics from TypeScript. It's not one-to-one to TypeScript, but that's our inspiration. and the goal of that is to make it accessible for dApp developers. Because sometimes when you have new blockchains, people are like, "Oh, why are you creating a new smart contract language?" It's like, what we're trying to do is emulate the TypeScript environment as much as possible, and I think there's a great stack in Midnight in general. So shout out to all the Node team engineers and stuff, and people who are working on the proof server and ledger, but that's all written in Rust. So Midnight, as far as like protocol runtime, the stack's kind of Rust, and as far as the dev development side, everything's TypeScript. So, and those are two extremely popular languages. I think there's one study where it said it was a developer study showing the number one most taken on language was TypeScript. So that's one of the reasons why Midnight is modeled to target that. Now, as far as interoperability, so interoperability poses challenges in most ZK smart contract systems, and including Midnight. So there's like the arithmetic straitjacket where all state updates are embedded in circuits, and this is like this limits complexity and efficiency. Plus public state conditions, so similar to UTXO conflicts on Cardano, where concurrent changes can be like invalid proofs, and this slide kind of outlines these problems in the context of compact. Now, compact realizes the Kachina model. This is a great paper published by OHK, so I encourage anyone to read it. But it's kind of a mathematical framework for privacy preserving contracts based on universal, composable security. So smart contracts in compact have like three-part structure where you have your public impact VM code on chain, your private TypeScript code on the user device, and ZK circuits linking them. So those are basically the three parts, and you can go to, I think, midnight.network, and I think there's a paper section. It's also in the docs. In the Midnight docs, if you go to the learning section, you'll find the Kachina paper link there as well. But it's a great read if you have time to, or I would say put it in your to read list. Now, as far as, so a key innovation in compact, which is drawn from Kachina, is transcripts. So transcripts are basically a record of interactions that helps escape circuit constraints and avoid race conditions. So there's a public transcript of impact operations and a private one of TypeScript calls. So to prove operations on states, not the states themselves. So the proof ensures consistency between public and private transcripts. Now, compact's on-chain code. A lot of people ask about the VM. So a lot of people ask about Midnight. They'll be like, "Hey, is Midnight EVM?" We're like, "No, we're not EVM. We have Impact VM." So so when you compile compact, it's basically in the VM it interacts with, that's Impact VM. So just to emphasize that. So compact's on-chain code runs on the Impact VM, which is an instruction set designed for public state contention. So it features a small type set of instructions with rich ADT like maps and sets. So operations at a high level and often communicative, such as map lookups or counter increments. So the cool thing about Impact VM, I think Paima, they just written their stuff in Rust and they just compiled it directly to Impact VM. They're pretty hardcore, but yeah. So as far as people ask what VM do you use on Midnight, it's Impact VM. All right, now as far as compact contracts, so compact contracts are strongly statically typed and bounded. And this is designed to work with TypeScript. So they consist of the ledger for on-chain programs and a witness for off-chain TypeScript programs, and circuits to link them via ZK proofs. Now there's a bunch of different primitive types in Compact. So Compact includes a range for building secure computations. These could be booleans, unsigned integers, various bits of length, field elements, tuples, bounded vectors, fixed length byte arrays, and opaque strings. I guess that's similar that you would expect from a language. So here's some examples of user-defined types. So beyond primitives, Compact supports user-defined types. So this allows developers to create custom structures tailored to their dApp needs, which is a good thing to know that you have the power to define those things. And we also have modules. So modules in Compact help organize your code better, enables a little bit more modular development of smart contracts with clear separation of concerns. And then we also have assertions and constants. So assertions, so this kind of supports, so assertions support validation and constraints for fixed values. So it's really to ensure reliability and correctness in circuit logic. And we also have conditionals. So conditionals in Compact allow for branching logic with circuits, but also maintaining privacy. So this enables like flexible decision making. And let me see what else do we got here. That's kind of all I have in this presentation. And I'm going to write a Compact contract for you guys. So this presentation was actually much longer at Rare Evo, which we're going to have the recording for eventually. But I kind of wanted to share everyone here that wasn't at Rare Evo, and maybe this was helpful to you. If you're new to Midnight, welcome, and I hope you learned something. So now I'm going to share my, let's see, am I already sharing this window? I might as well share you here. So to get started in Midnight Network, we have the Midnight documentation website. Just seeing on the restream if it's showing my screen. It is. So here we have the Midnight developer documentation. We have a quick start that'll get you up and running to use the Midnight Lace wallet, get TDS, etc., and a bunch of other tutorials. I'm going to not even dive deep into a deep, long tutorial. We're just going to write a simple hello world. So, and I'm also going to use this new Compact developer tools. So those of you who've been here before, we had originally when you had Compact compiler, you'd have to download a binary, but now you can use the Compact developer tools. So shout out to the compiler team for releasing this. It definitely has made a better experience. So I'm just going to go straight into writing a hello world thing. I could also, within the documentation too, you'll also find, let's see, I think it's in releases at the moment, but there's the Midnight VS Code extension. So I already have that installed, and I'm going to just go to the Compact Developer Toolkit. It's a great article here, it talks more about it, but also a very convenient installation script. So here is VS Code. Oh, my VS Code's not being shown. Let me share that. VS Code. All right. Now my VS Code is on screen. Cool. So you can see here, I already have the Compact extension installed. soon will be on the official extension store. But yeah, so here we are. I'm in Compact. I have my terminal open here. I'm going to just install Compact here really quick. Cool. And you can see here it says to export this into your path. This will only temporarily add it to your path, so you might want to append it permanently wherever your shell profile is. All right, so let's try this Compact version. All right, so now the Compact compiler is installed. It's a pretty cool tool now. It has a lot of different features. You can check your Compact for updates. You can list different versions. And it's almost like, I guess you could say it's almost like a Compact version manager in a way. But it's a lot better, this tool. So, and I think our development is fairly new. So so if you've been using the binary before, definitely tell you to give the new Compact tool chain a try, and tell us about your experience. But anyways, I'm going to make a directory here called Hello World. All right, we're going to go into Hello World. All right, and now what I'm going to do is, do I have to, it's not showing in my Finder. 1 second. Let's try this. That's better. All right, I'm going to share my other window because it wasn't showing. All right, here we are. I wanted to have the file system shared on the left side here. All right. So now I'm in Hello World. I'm going to make my screen a little bigger. Now, I told you guys that you should add it to your path, which I didn't permanently. Oh, it still picked it up. Great. That's good. So Compact is installed. I have my Hello World project here, and it's just empty. So here I'm going to walk you through writing each part of this Hello World application step by step and explain what it does as we go. And by the end, you'll have a working example to play with. So here we have Hello World. First, we'll start with the pragma directive. So let's do that. So let's do a new file. I'm going to call this hello world.compact. And I think this is recorded, so if you just want to watch, feel free to, and look back at it. So now we're going to write the pragma directive. So I'm going to do pragma language version. Now this is your Compact. This is where you define the Compact version. What's cool here is you could do like equals 0.17. But Compact, but well, you can also, so I can do it like this if I wanted to, but there's something else that's pretty cool, is I can do version is greater or equal than 0.16 and less than, or say less than or equal to 0.17. So you can have a version range defined, which is a pretty cool feature. Some might use it, some might not, but I think it's cool to show it off. So this tells the Compact compiler which versions of the language this contract is compatible with. So it's like setting the rules for our code, and here we're saying it works with versions, kind of self-explanatory, but versions 0.16 and up to 0.17. So this helps avoid breaking changes if the language evolves. So that's a cool thing to do. Next, we're going to add the import statement. So we're going to do import compact standard library. And all right, import compact standard library. And this pulls in Midnight standard library, which gives us handy built-in types and functions. So you can think of it as importing essentials like strings or data structures. And, we will need it for things like the byte array for later. So I'm going to save that. Now we're going to define our public state in a contract. So here we do export ledger message, and we want message to be, let's say, bytes, 11 bytes here. All right, semicolon. So here we're declaring a ledger variable called message. So that that's exported, meaning it's visible on the public blockchain. Okay. And the type bytes means it's a fixed length byte array of just 11 bytes, which is perfect for storing a string like hello world, which is exactly 11 characters. Now, the ledger is where our contract's persistent data lives as well. So since it's public, anyone can see it after we update it. All right. So let's move on to the core logic, which is basically the circuit. And we'll start that with export circuit store message. All right. So this defines when I wrote here's the export circuit store message. This basically defines an exported circuit named store message, and circuits are the heart of compact contracts. So they're kind of like functions that run in a zero knowledge way. And these here, as you see, these brackets here means it takes no parameters and returns it as an empty tubule, which is basically nothing. So the curly braces opens the body. Now, inside the circuit, we will add a message. So we're going to do message equals hello world. It's just a hello world string, a semicolon here. And this is kind of like the magic line. So you see here in line 8, this is kind of like, this is basically the magic line where we're assigning the string hello world to our ledger variable message. So in compact, string literals like this are automatically treated as bytes, where n is where you can see like bytes, n is like the length, so it fits perfectly into our bytes array 11. So when the circuit runs, it updates the public state securely. And then finally, we're going to close the circuit with our curly brace here. So that is basically our circuit. Now, let's talk about what happens when we compile this. So I'll just save this hello world compact. And in compact tools, I'm going to do compile, compact, compile, hello world. I'm just hitting tab to auto-populate it. And I'm just going to do compact compile. I'm not going to define a directory I want to compile everything to. I'm just going to do hello world compact compile, and then dot is in like the active directory I'm working on. So let's run this. All right, now you can see here, we do have some feedback here. It says compiling one circuit. circuit is stored message and shows you the progress. And you can see here it generated a bunch of artifact files. So as we see here, the compiler directory, this holds the compact compiler tools and any intermediate files from the compilation process. So it's like the behind the scenes workspace where the compiler turns the high level compact code into lower level representation. And we also have the contract directory. So this contains your compiled contract artifacts. And we also have the keys directory where you'll find like cryptographic keys, such as proving and verifying keys. And we also have ZK-IR directory. This stands for Zero Knowledge Intermediate Representation. So it stores the ZK circuit artifacts, like the intermediate code that represents your contract's logic in a form ready for proof generation. Okay, and all these artifacts together make up the build output, and they're a key for everything from local testing to full deployment on midnight. So if you're following along, feel free to try compiling now and feel free to explore them. But that's basically a Hello World example live with you here. Now this is a very simple setup just to simply store a message. And I'm just showing you compiling it right now, but typically you deploy this on the Midnight testnet, call the circuit from your wallet, and see Hello World appear publicly, and maybe even have a UI. But I think in the future we can take this example and grow to doing demos of that as well. But I'm also doing this here with you as well because behind the scenes I'm going to be working on our quick start or getting started guide. So the current quick start kind of gets you up and running with using the lace wallet, getting TDUS, using the proof server and stuff, but also like to do something where you can quickly get to a Hello World application, compile, and maybe even dive a little deeper into UI components and interacting with things. So there's a lot coming from just this demo here. And that's kind of all I got for you guys for this segment. Are there any questions in the chat? I don't know how long I've been going for. Let's see, we're 49 minutes after. Let's see. I see the YouTube chat. Yeah, that's a Hello World example. It'll eventually be on the docs. And if you were following along, I hope you liked it. And if not, feel free to watch the recording.
All right.
Oh wait, I gotta turn my screen off here. There you go.
Oh, okay, cool. Stev, can you hear me?
Yeah, I can hear you good.
Awesome. Yeah, there was some comments on some folks about the font size you were using, but I think probably post video they should be able to view it more. I was talking about your VS Code. The font was a little bit tinier.
Sorry about that.
No worries.
Yes, I was in the zone with the VS Code. I have Restream and I have Restream to left. So I was I wish I saw that earlier, but I think people can and anyone can zoom in the video, and I hope I can get that quick. I hope I could get this app live on the docs, hopefully by the end of the week too, because we're having the Argentina hack this weekend, and a lot of people ask for similar material. And if anyone else is going to the Argentina hack or participating, glad to see you there. And if you are coming or thought about coming, go to the hackathon page on the website. I think you can sign up there. Yeah, there's a lot of stuff going on for midnight.
Yeah. Cool. Yeah, I know. It was, thank you for the quick demo. It's always good to see that. But yeah, really excited, and thank you everyone for joining. Definitely gonna be doing this more. And again, this is my second week in the organization. Uh, Good to be part of the community and also learning also. Cool. All right, that's it. Thank you all, and see you same time, I believe, next week.
Yep. See you next
Yeah.
week.
All right. Bye, everyone.